We're still in the process of discussing SPC. We're still in the process of discussing SPC, and the type of SPC chart that we are discussing now is still X bar and R chart. There are 7 steps involved in the process of developing an X bar R chart, and at this moment we have done the first 5 steps, and today I will take you through step number 6. Overview on step number 6. Step number 6 is talking about analyzing the control chart that you have plotted so far. So the purpose of analyzing is to identify so-called the trend of the control chart. Trend of control charts. So the chapter can be, in general, the chapter can be split into 3 main sections. Section number 1 is going to talk about, let me try to write. Section number 1 is talking about why you need to study the trend of the control charts. And the second part of the chapter is going to talk about how you're going to analyze the trend of the control charts. And on top of that, we're also going to discuss on what actions, let me try to write again, what actions are required, or what action could be taken once you have identified a trend that indicated that potentially there'll be a failure on the process. So there are three parts that we're going to talk about. One is why you need to analyze the control chart to identify the trend. Number 2, how to analyze the trend. And number 3, what actions are required once the trends have been identified. Okay, let's go for the first. Let's try to answer the first question: why you need to study the trend of the control chart. Look at these 2 control charts. What we have discussed so far, one of the methods to identify either control chart is statically in control or statically out of control is look into is there any point that beyond the upper control limit and lower control limit. If we try to analyze these 2 control charts based on what we learned in previous chapter, you can notice that none of the point is plotted beyond the upper or control limit. So if that's the case, perhaps you're going to draw a conclusion and say that the process is statically in control. That is not true, because the other advantage or the other so-called powerful points of this control chart is basically control chart able to show you some hidden problems that you might not be able to observe from the process itself. And these hidden problems that underlying the process could be identified by look into the trend of the point that brought out the control chart. A quick example, this is called the trend. Maybe you need to worry. And here is another trend that maybe you need to worry. So to summarize what I discussed so far, why you need to study the control chart, the trend of control chart, is because assessing a control chart, not purely assessing either is there any point go beyond the control limit. On top of that, we also need to look into the trend of the distributions of the point brought on the control chart in order to identify so-called hidden issue that need to be discovered in order to prevent failure from occurring. Correct? So that is why we need to sort of studying or analyzing the trend of the point product of the control chart. If that is the case, then how are we going to analyze the trend of the control chart, or how are we going to analyze the point that plotted in a control chart? This module is going to share with you two common methods that used by industry that as a reference to analyze the trend of the point that plotted on the control chart. And these two methods is with the name of Schuhert's rule and Western electric rules. And this Schuhert rule make up 6 rules. This 6 rule is a guideline, a reference of the guideline that so like give you the idea how can you identify a potential problem based on control chart. And same go to Western electric rule, which is a make-up 4 rule, which is served as a guide or reference of identifying potential problem of the process based on control chart. On top of Schuhert's and Western electric rule, there's another rule they call Nelson rule, which is quite common also quite a common rule that used in the industry, but we're not going to talk about this rule. It's not under this module or this chapter. Okay, so let's take a look on what the 6 rules that proposed by Schuhert and what are the 4 rules that written in the Western Electric Handbook. Let's start with Schuhert's rule. Schuhert rule number 1 is quite straightforward. It's something that you learned before. The rule number 1 is Schuhert saying that if there's any point that go beyond the upper control limit and lower control limit, it could be over the upper control limit, it can be go beyond lower control limit. If that's the case, then that's indication that you have a problem in the process. Quite straightforward. If really this is the scenario they observed from the control charts, it suggested that there's abnormality occur in the process, and what you need to do, the action required for you to do is you need to compare what has been changed from the previous setting. What has been changed from the previous setting in terms of perhaps process setting. Is there any change on the process setting? Is there any change on the material use, operator use? So this is what this slide tries to say. Okay, recap this slide saying that the first rule of Schuhert is any point beyond control limit is indications of there's abnormality in the process, and the action required is to compare the setting of the points that go beyond control limit with the settings of the process at the point that before it is out of control. Okay, the setting can be referred to machine setting, material use, method use, or the operators. Okay, this is number 1. Let's go to rule number 2 of Schuhert. Rule number 2 of Schuhert is with the names of run. If you're able to identify a trend with the name of run, then there's indications that there's a potential problems in the process. Okay, run. What is run means? Run means that if there's continuously 7 point running at one side of the center line, it could be this that I just circle, or it could be example 7 point above the center line, then that is another indication of the process is abnormal. And what action required? the action required is look into the process methods of machine. What does it mean? It means that this scenario run potentially caused by this change in the process, this change in the method, or perhaps this another machine use. Example, okay, look at the slide here. Perhaps the first 4 points here, the data is collected when the process is carried out by operator A or machine A. However, the subsequent 7 points, the process was carried out by different operator or different machines or different methods. Okay, so that there is a action required, quite similar to the previous rule that if this is occur, you need to compare with the previous setting. This is the second rule, run. How about the third rule? The third rule of Suhed suggested that if there's 7 points continuously moving outwards, or if they are 7 points continuously moving forward, this is another indication of perhaps a able cause exists in the process. And the root cause or the actions that require for these types of train is basically look into the tools that use on the machines. This train most likely is caused by the tools on the machine used is way or is towards the end of the line, and action required is to change the tool or change the spare parts of the machines. Right? Okay, this is rule number 3 of Shuhat's. How about rule number 4? Rule number 4 of Shuhat is related to a so-called cycling effect. They call it a periodicity effect. Cycling effect means you have a few points plot and group together, and you have a few points that also form another group. And if you try to connect this point together, you will start seeing sort of like a cycle. And the special thing about this cycle is the interval between the cycle, which I draw here, the interval between the cycle, you see, or the interval between the peak is quite consistent. It's quite consistent. And if this is the case, Shuhei also suggested that this is indication of abnormality, and this most likely is caused by seasonal change. What does it by seasonal change? Seasonal change, it could be sort of like the first group, the data of the first groups are collected at mornings, example at morning, AM, when the second group of data is collected during afternoon, or day shift, night shift, day shift, and night shift. So it's sort of suggested that it's inconsistency in the process setting, in the method used during morning and afternoon. That's what we call seasonal change. Okay, this is rule number 4. How about rule number 5? Rule number 5 of Shuhet is quite similar to rule number 4. That it called it as a wave. Wave compared to cycle. Number 1 means I try to compare phenomena or rule number 5 and 4. Rule number 4 is cycle. If I compare wave with cycle, wave have a bigger interval, a longer interval, a longer distance between two peaks. Number 1. Number 2 is the interval between wave might not the same, inconsistent in terms of interval between the peak. If this is the scenario, and this is suggested by Shuhet, this is another indication of abnormality occur in the process. And due to inconsistency of interval, you can't compare with the previous process to look at the setting. So therefore, normally you will say that if this is the trend, then it's quite difficult to investigate. So if quite difficult, then what should you do? You should explore the 4M machine methods, machine method, material, and man to see what are the potential problems that occur between these two peaks. All right, this is rule number 5. How about rule number 6? Rule number 6 of Schuhetz is with the name of abnormal dispersions. Abnormal dispersion means changes that happen suddenly, that abnormal in terms of the dispersions. Now look at the first few points. You look at the first few points here. The point the collector are moving up and down with quite a consistent interval, not constant interval, quite consistent magnitudes. But from point 1, 2, 3, 4, 5, 6, from point number 6 onwards, there's a sudden jump from here to there to here. You see? And what you can see from here is the dispersions of the process from point number 6 onward is much bigger than the dispersions of the process before point number 6. If this occurs, then also suggested that there is an abnormality occur in the process. Again, it depends on the interval occurring. If the interval occurring is quite consistent, you can just compare the point with bigger dispersions with the point with smaller dispersion to see what is the difference or what are the differences between these two settings. But if the intervals of the abnormality doesn't occur consistently, then again you need to explore the 4M to see what are the potential problems of these abnormal dispersions. All right. So that is what proposed by Schuhetz in terms of 6 rules or 6 guidelines that you can use to identify potential abnormality that occur in the process. I don't know what do you have in your mind. Perhaps you would think that the way that proposed by Schuhetz is slightly complicated, and perhaps in order to implement or to follow the rule that proposed by Schuhetz, you need to have a certain level of knowledge in terms of SPC, as well as you must quite familiar with the process that you've been monitoring. If not, perhaps you have difficulty to identify the trend from the control chart based on what proposed by Schuhetz. That's the reason that there's another rule that commonly used by industry in analyzing the point product control chart, which is a Western Electric Handbook. The concept of Western Electric Handbook is totally different from Schuhetz. And relatively, to use Western Electric Handbook as a guideline to identify process abnormality, relatively not require a very good knowledge of the process itself. So what's the fundamental concept of Western Electric Handbook? Western Electric Handbook splits, let me try to find my pen, split the area between center line and control limit. Means split the area between center line and this is upper control limit. With my pen again, okay, this is upper control limit, and this is lower control limits. Western Electric Handbook splits the area between center line and upper control limit into 3 zones, zone A, B, C, as well as the area between center line and lower control limit into 3 zones, A, B, C as well. And how to split is by identify additional 2 lines that we call it as 1 sigma line, 2 sigma line. Okay, and 3 sigma. 3 sigma basically is referring to the upper control limit, lower limit. So how to identify 1 sigma and 2 sigma? Use a simple mathematics. Example, I can just find the difference between upper control limit, the difference between outer control and center line in upper control limit line, and I divide by 3. By doing this simple calculation, then I will be able to identify the distance between the 2 sigma and 3 sigma line, the 1 sigma and 2 sigma line, as well as the center line and 1 sigma line. Okay, so what's the fundamental concept of Western Electric Handbook? There are 4 rules, as I mentioned earlier. The first rule saying that 1 point plot outside the 3 sigma control limit. What does it mean? The first rule of Western Electric Handbook is similar to the first rule of Schuhert's rules, which saying that if one of the points go beyond control limit, it could be here, it could be here, then that is an indication of abnormality. Clear? This is the first rule of Western Electric. How about the second rule? The second rule of Western Electric Handbook suggested that 2 of the 3 points plot beyond the 2 sigma warning limit. 2 sigma could be this, there are 2 sigma, and the 2 sigma, and the name of the 2 sigma line is called warning limit. 3 sigma control limit, 2 sigma warning limit. The second rule, Western Electric Handbook suggested if there's 3 point example, 3 continuous point, 1, 2, 3. Okay. 2 out of the 3 points beyond 2 sigma line, then that is an indication of abnormality. Another example, it could be 1, 2, 3. Then this is an indication of abnormality. Again, you can see that you can identify this without a fundamental idea of the process, fundamental concept of the process. When you look at this point, you can sort of conclude that there is an abnormality. This is the second rule. How about the third rule? 4 out of 5 point plot at the distance of 1 sigma. Okay. Means, where's the 1 sigma point? This is 1 sigma point, 1 sigma line, sorry. This is 1 sigma line. 4 out of the 5 means 1, 2, 3, 4. It could be like this, 5. 4 out of 5 point go beyond 1 sigma level, then that is another indication of abnormality. And this is the third rule of Western Electric. This is the second rule. Okay. How about the last rule of Western Electric Handbook? It's saying that 8 point plot one side of the center line. Where's the center line? This is the center line, again with my pen. Okay, this is the center line. 8 point could be 1, 2, 3, 4, 5, 6, 7, 8. If 8 point at one side of the center line, then this is another indication of abnormality in the process. Quite clear cut for Western Electric Handbook. And this is what we have discussed.